In my last video, we mainly saw what is blood coagulation, what are the clotting factors, and I have taught you all how to remember those clotting factors. And next we have seen what is enzyme cascade theory, and the last one we have seen the stages of the blood coagulation. So now in this video, I am mainly going to describe what are the three stages of blood clotting. So watch till the end and try to understand the concept.
So the first stage is mainly formation of the prothrombin activators. So this is stage you have to reach here. Okay. So now first thing, to form this prothrombin activators, you have two pathways. One is intrinsic pathway, another one is the extrinsic pathway. So let us learn about this intrinsic pathway first. It is mainly activated by the platelets inside the blood. Okay, inside your blood, whatever platelets are there will activate this intrinsic process. Okay, inside, right? So, next, the sequence of events in this intrinsic pathway, they are like, what happens is that during the injury, the blood vessel will get damaged. Whenever you have injury, your blood vessel will damage. Your blood vessel is made up of endothelium, right? So it contains collagen beneath this endothelium layer. Okay. So this collagen will be exposed now. As you can see in the first step here, when endothelium damage is there, collagen exposure will be there, and hence further events will take place. So the next thing is that this exposed collagen, whatever is there, it will combine with this factor 12, or you can say this factor 12 will combine with the exposure of the collagen. When this will be combined, or when it reacts in the presence of this kallikrein or high molecular weight kinogen. Okay, in the presence of this kallikrein or high molecular weight kinogen, this inactive factor 12 will be converted into active factor 12. A is nothing but indicating the active form. So inactive factor 12 will be converted into active factor 12. Okay. So further, this active factor 12 in the presence of high molecular weight kinogen, okay, in the presence of high molecular weight kinogen, will convert the inactive factor 11 to active factor 11. Is it clear? Inactive factor 11 to active factor 11. Now this active factor 11 in the presence of calcium, okay, in the presence of calcium, what happens? It is converting this inactive factor 9 to active factor 9. Inactive factor 9 to the active factor 9. So further, in the presence of this factor 8 and calcium, what happens is that active factor 10 is formed. So inactive factor 10 will be converted into active factor 10. One more thing you should know, when your blood vessels get damaged, collagen exposure will be there. So this collagen also combines with the platelet inside the blood. And hence it will activate and release this phospholipids. You can see here, collagen exposure will react with this platelets and lead to the phospholipid formation, right? So this phospholipid along with this factor 5 calcium, okay, and this factor 10, activated factor 10, all together lead to the formation of prothrombin activators. All together will lead to the formation of prothrombin activators. So this was about the intrinsic pathway. Now let us see about this extrinsic pathway. In this, what happened is that the formation of prothrombin activators, there it was initiated by platelets. Here it is initiated by the tissue thromboplastin. So this tissue thromboplastin is formed during this injured tissue. Okay, when there is injury in the tissue, it has been formed. So what are the sequence happening here? Let's see. This damaged tissue, whatever is present during the injury, it will release something called as thromboplastin. That is nothing but factor 3. Okay, so this, see, the tissue thromboplastin, whatever is released during the tissue trauma. Okay, so this thromboplastin mainly contains proteins, phospholipid and glycoproteins. In that, these all are proteolytic enzymes. Okay, so in these enzymes, the glycoprotein and the thromboplastin, okay, mainly converts this inactive factor 10 to the active factor 10. Also, the presence of factor 7 is also there here for this conversion. Okay, you can see here the two things, that is these proteolytic enzymes in the presence of factor 7, it is converting inactive factor 10 into active factor 10. Okay, so further it will react with this factor 5 and phospholipids. Further it will react with what? The factor 5 and the phospholipids here. This phospholipid. Okay, in the presence of calcium, in order to form the thrombin, prothrombin activators. As you can see, to form the prothrombin activators. This thrombin mainly activates the factor 5, that is nothing but calcium. Okay, so it is written here. Okay, in stage 2 what happens is that conversion of prothrombin into thrombin. You should know that this prothrombin activators, whatever are formed from the intrinsic pathway as well as extrinsic pathway, will lead to formation of this prothrombin activators, right? So this prothrombin activators will convert the prothrombin into thrombin. This thrombin will lead to formation of still more thrombin molecules, due to which again factor 5 will be activated here. Okay, so this activation further leads to again production of prothrombin activators. So there is positive feedback mechanism going on here. Okay, so this was all about this stage 2, that is conversion of prothrombin into thrombin. So the last stage is stage 3. In this what happens? There is conversion of fibrinogen into fibrin. Okay, so what happens here is that whatever thrombin is formed in this stage 2, this thrombin will convert the inactive fibrinogen into active fibrinogen. Okay, so this active fibrinogen. Now, this fibrinogen is called as fibrin monomer. So like that, this monomer will polymerize with the other monomer molecules in order to form a loose strands of fibrin. Okay, so after formation of the loose strands of fibrin, there is, in the presence of factor 13 and calcium, it will lead to formation of the tight blood clot, that is meshwork will become tight here, and that is called as fibrin, by the fibrin. So this is nothing but conversion of fibrinogen into fibrin. This was all about the stages of the blood coagulation. So next we can see further topics in the next video.
This was all about the stages of blood coagulation. Thanks for watching the video. Please do like, share and subscribe the channel. Thank you.